Hey guys, thanks for joining. This lecture will talk about classes, and it's going to be a bit more involved and heavy, but we'll do it by practice. We will not talk too much about theory of object-oriented programming, but we'll introduce the concept of a class, show you a few examples, and yeah, we'll be done with it, and hopefully you'll get an understanding of what the class is and how to use them. And I've just checked the dictionary definition of a class, and it's not a definition from programming, but actually in programming that's exactly what it means, that it's described as a set or category of things having some property or attribute in common and differentiated from others by kind, type, or quality. So basically, you define a class as a definition of an object, and it has certain qualities to it, and you can instantiate multiple instances of that class, and all of those instances can differentiate from each other by that type, an attribute. And let's just start our lecture again with this boilerplate, and I'll just type it. I know you guys probably hate to type this, but yeah, I think it's good to do this in the beginning. And so to define a class, what you need to do is, of course, type class. And now if you want to relate to the lecture where we talked about JavaScript objects, we can say that we have a person class, for example, and the person has a field or a property, a name that is a string. It can have a surname that is also a string, and it can have age, for example, that is a number. So this is relatable to the person that we had before. The only thing now, we can say that it has a constructor, and constructor, we'll see how to use it just really briefly. You can say that constructor can initiate a name, a surname, and age, which is a number. And you can then link the name to the name, the surname to the surname, and this age is an age. So in this way, you instantiate all those private properties. So we'll talk about that also in a minute. So here we defined a person class, and we can say that we want to create a new person. So as we did before, we say that there's a person 1, and it's a person that has a name Steve, Johnstone, and the age is 30. So we have now in this single line created a person without typing out each property multiple times. We just use the constructor to construct this person, and we can have person 2, John, and so forth and so forth. So in order to get the name of a person, we were typing person.name in the previous example, but you see that now it says that the name is private and only accessible within class person. And that is nice because classes allow you to protect data and properties and attributes and fields and even methods from the outside world. So you can encapsulate the functionality within the class, and you choose freely which parts of your person you want to expose. So maybe you just want to have a get text method, for example, that will return that template string that we've used before. So this name, this surname, and born or of age in this case, right? This dot age. And here now we cannot get the name, but we can use this getText method, because by default, if you don't define it as being private, then you can use it. So you can say text is person1 getText. If you make it private, immediately TypeScript says, yeah, you cannot access it because it's private and only accessible within the class person. So with this private method, you disallow others accessing the method. You could just say that you make name public. Then what's possible is to say person1.name. The name of person1 is person1.name. So this is fine as long as the properties are public. So when they are public, you can use them. But also in this case, what's a bit dangerous is that you can change those names while the code is running to Dada, for example. And that's allowed because this property is public. And if you don't want these kinds of behaviors from appearing, then you have to protect your properties or attributes of a class. This is how the classes work. This is very, very fast introduction to the classes. We'll create a class that will represent a 3D object, and we will make planets in space. This will be our example. So we will not be working with persons anymore. I just wanted to relate to the previous lecture and explain really briefly how the class looks like, so you won't be blown by the class that we will be creating right now. So let's rewrite this code. Let's call our planet class a planet. And what we will do is we will create a set of properties or fields on the class that will represent it. So planets probably are not represented by the name and surname. So planets are going to be represented by other things, such as the radius of a planet. The sphere will be of type OCT TypeScript solid pointer. Rings will exist as a separate geometry, so rings like on Saturn, right? That will also exist as a TypeScript solid pointer. And these will come from Open Cascade kernel, but we will draw them and they will be represented by Babylon.js meshes. And a recent addition to our framework is that you can use the types of Babylon also directly in our editor. So we can do sphere mesh and rings mesh properties like that. Another thing that will be needed, we'll say that we have colors. For a color, we'll define a new enum. So enumeration is something that we did not yet talk about, but enumerators are handy in some situations like this, where we want to just pick a simple item from possible choices. So let's say we have a planet color enum. Let's call it planet color enum. So there will be planets that are colored purple, and this will be the color. So hexadecimal notation again. There will be white colored planets, and these will be notated like that. And there will be blue color planets that will be annotated with this blue channel color. Okay, so now we have an enum, and we can say that the color of the planet is defined by the planet color enum. And this is just not assigning anything, it's just saying what kind of type these properties will get. So as we did with the name and the surname, that these were strings, now we are just defining our set of fields on the class that will be used. There will be also a center of a planet, and it will be represented by the point 3. The user of a class can also then have a rotation speed of rings, and that's a number. So some planets will have rings that are rotating faster, and some planets will have rings that rotate slower, and we'll have rotation vector that will be represented by Babylon vector 3 class, because we'll be using Babylon to just rotate those rings around in space. And in this case, we'll be merging basically the features of BitByBit and the features of Babylon directly in our editor. What we will do now, we will also say that all of these properties are private, and I can use Alt to select multiple places where I want this private to appear, and then just copy paste it like this. So, okay, so we defined all of our properties, and now what we can do is make a constructor that creates those. We'll be needing not everything, right? Because some things will be created on the go. We only want to provide the constructor with the radius, which is a number, with the rotation speed, which is a number, with the center of a planet, which is, yeah, let's make this into a type that we define on top, because we will be repeating it throughout the code base. So let's say that 0.3 is like that. Okay, yes. So now we can see here that it's shorter. So you can do this with all the types. You can just define them here on top so that the code base would become shorter. But yeah, I don't mind having even full types here. They fit the screen fine, so it's okay. And let's say that the center is also 0.3. And another thing that will be different for each planet will be the color. So we'll use the planet color enum to create a class. Okay, so now we have these, and we can assign those as we did with the person. So what's happening here, this represents a inner scope of a class, and you can access its properties freely throughout the class, even the private ones. So that's fine. Within the context of your class, you can use those. And because we define rings here, it's still undefined, right? It's not assigned to anything. So because we don't do something like that, it remains undefined. So we have to define it. We have to give it a value, and the constructor will give us that value. So basically it passes us a radius, and we assign it to this scope. We also do that for rotation speed. We assign it to rotation speed. This dot center is center, and this dot color is color. And I'll also identify that it's rotation speed of rings. So let's rename it ring rotation speed. Okay, and we can already instantiate the class like this. So we can say our planet 1 is a new planet, and it may have a radius of 1, rotation speed of 0, 0, 1, and the center on 0, 0, 0, and the color, we can use the planet color enum blue. One thing we should do is place this definition of an enumeration on top, and we can also just move this whole code base at the very last moment. So basically we will define all our classes and things here on top, and then we'll use them here on the bottom. Maybe that's a better way to structure this. So one thing I sort of forgot to do is I want to also, while constructing this object, just create a ring rotation vector. Each planet will get a random rotation vector, and to do that I'll just use Babylon vector 3, create it like that. Yeah, first I'll just do normalize. I'll pass it a vector, and I'll use math.random for x, math.random for y, and let's see, math.random for z. So Babylon has its own way of defining vectors, and sometimes we clash with Babylon because we use arrays with 3 numbers to represent vectors, and Babylon has its own way to do that. But it's fine to learn all kinds of ways to do things. So this is the way we do it in Babylon. We create a rotation vector that we'll use to animate the geometry. And that's also maybe important to explain, is that BitByBit is mostly a CAD system. So we are concerned about creating geometry, and then drawing that geometry is left to Babylon anyway. So this is what we do. This is our game engine that we use to represent everything on the screen. And that is why we can natively use Babylon here as well, because we allow you to just get most of the game engine and access most of its features through our editors. So now we've created a rotation vector that will be random each time for each planet that we'll be instantiating. So if we have the second planet, which will be like this, so planet 2, and its radius maybe is 1.5, and the speed of rotation is 0.02, and maybe it's hanging somewhere a bit higher, and the color may be white then of this planet. This planet will get a random rotation vector for its rings. So I'll also rename this one, because I think it's good to say that it's ring rotation vector, not planet rotation vector. We will only be rotating rings because that looks fun, and rotating spheres without textures will not show us anything, so this is why we do it like that. Okay, so we created some fields. We assigned the values to the ones that we think are needed and represent the differences between the planets. The other fields that are here we'll create on the fly. So each planet will have a synchronous method called instantiate and draw. This will be a public method that we will call in our start functions to instantiate geometries and draw the meshes. And we'll also have a few private methods that will also be async, and that will be create sphere. And there will be a method called async create rings. And there will also be a method called draw. Okay, so we've created a few internal methods. This one's public. None of these methods yet do anything, but how it will work, we'll do this await, this create sphere, await this create rings, and await this draw. So you see that we'll be creating a sphere, creating rings, and then drawing the geometry. So basically first with create sphere, we'll create a sphere that will be a solid pointer. With create rings, we'll create this property. And with draw method, we'll be drawing these two meshes and assigning those meshes value. Also, maybe important to realize is that this and this are never being drawn on the screen, but sphere mesh and rings mesh are the things that you actually see. So this represents mathematically what the sphere and Open Cascade looks like, and this can be also used with Open Cascade, but these are just meshes. These are triangulated geometries that you see appear on the screen. This might be a bit hard to understand, but just bear with me and you'll see that in this example how that works. Okay, so let's create a sphere and let's just assign it a value. So it will be like this. So again, we'll go and call bitbybit with a weight. So we'll go to Open Cascade. We'll say that we are interested in shapes, solids, and create sphere. And we'll use a radius. That will be a radius. We'll use the center. That is a center that we gave to our planet. And that's it. This is the only things that you need to create a sphere in OpenCascade. And for the rings, we'll just use a cylinder. So rings will be implemented like that, bit by bit, OCCT, shapes again, solid, and create cylinder. And I'll use the radius. That will be this dot radius times 1.5. So it will be just a bit larger for each planet than the radius of a sphere itself. That way we don't need to define anything separate here. So maybe it's also good to say that this is a planet radius, not ring radius or something. And here as well we can rename that with F2, planet radius again. So planet radius is planet radius, and then we can use it here. The other thing that this rings entity needs is a height, and that should be something like 0.05, and it also needs a center, and the center will be the center of a planet, but we'll move that cylinder just a little bit down to center it correctly. And this is due to the fact that cylinders are created on the ground as their centers. And okay, so now we have rings, we have a sphere. They're still invisible. We still need to type this code, and this is what you do a lot in programming, right? You type and you imagine what will happen, but you don't see things till you're programming. This is what makes bit by bit maybe unique, is that you can begin visualizing quite soon, quite fast. And TypeScript also helps saying that the code is good or not good. Anyway, we'll see it when we run it at the end. But now another small thing that is left is we want to draw this planet. So let's go ahead and draw the rings and sphere. So how we do that is this rings mesh is await bit by bit draw any async, and the entity is this dot rings. So this is important. Class knows when to call the draw method. You first await the sphere and rings, and only then you know that you have these properties like rings, and you can use them as entities. If the rings isn't defined, then this draw method shouldn't do anything, and you can protect from it. So you could say that you will not call it if rings doesn't exist. So this is how we do that in TypeScript. You can write the small condition if, and then if rings exist, then you can create the meshes. If not, then nothing will happen. So we'll do that similarly with the sphere, and we create the sphere mesh with this same draw method. This dot sphere. Okay, so now we have a rings mesh and sphere mesh. We can now go ahead and visualize what we've got so far. And we can do that by going here and saying planet 1, instantiate and draw. And we can await on that if we want to. And we can do the same for planet 2, instantiate and draw. And we can run this code, and voila, we see two spheres with the rings and their edges and everything. So this is something that we get by default, right? So we have to remember that we have given each planet the color, and because we did that, we haven't yet used it, and that is why we see these planets appearing as red and having those white edges. In order to configure how we draw things, you remember probably already that we have these draw options to use. So we can go ahead and say options, and then we can take this class and just say constant draw options is a new instance. So here we also use classes, right? We instantiate these options, and you see here that it is a constructor that we call. And with that, we have a sort of default class that we create with default attributes or fields. And we will say that we don't want to draw the edges in this case. And we will also say that the color of our faces is the color of the planet. Now you can just assign those options to both the rings and the sphere. And if you run this code, you'll see that now our planets are colored differently, because here within the constructor we said that we want one color of the planet to be blue and the other planet to be white. Okay, so this is pretty self-explanatory. You see that we didn't yet use the ring rotation speed and ring rotation vector because that rotation method was not yet implemented. So now we will instantiate a method that will allow us to rotate the rings mesh around the center. So I will be calling this method rotate rings, and what this will do is it will first check if the rings mesh is available, and if it is, it will say this.rings mesh rotate around, and what we need to do is provide a center point of rotation. So we need to create a new Babylon vector, because this is a rings mesh, is a Babylon mesh, and it has a possibility to define the rotation. And we will say that Babylon has a vector 3, and we'll say that it's just center 0, center 1, and this dot center 2. So this represents the x, y, and z coordinates. We can type the same thing a bit easier like that, and I'll do it, so the code will become a bit shorter. And what we also want to do, ring rotation vector has to be the axis of rotation, and the amount of rotation will be the speed that we defined. So this ring rotation speed. This method in principle allows you to rotate your rings just a little bit, and if we call it, actually nothing would happen because our rotations are super tiny. So I can do that, and we can just go ahead and say planet 1 rotate rings and planet 2 rotate rings. And you see that they did shift a little bit. If I run it again, they also tend to shift a little, but that's a single shift every time we run the code. If we would define that speed to be higher, like maybe 0.25 and here 0.5, we go ahead, we click, you see that these rings adapted. But what's not so fun is that they are not rotating continuously, right? And this is exactly what I want to do. So now what I'll do, I'll lower the speed again to the values that we had, and I'll use bit-by-bit method that allows us to register the render function on Babylon.js. There are other ways to do it, also using Babylon itself, but this is one of the simplest that I can come up with here. And so we register a render function which taps into the rendering cycle of Babylon.js, and this will then update those rotations each frame of rendering. So if I hit run now, you'll see that these rings continuously rotate with the speed that we've provided for each planet. And this is quite cool, because you see that we can now create multiple planets, we can instantiate them, we can position them on different origins, and we can also just change most crucial representative aspects of them. What we also want to do now is we want to use this possibility, because now we have only 2 planets, right? It's not very, we know that in space there are way more planets spinning. So what we can do, we can use those same constructors in our iteration loops and create multiple planets in multiple places. And we'll use some random functions to do that. And we'll also use some sort of decision factors to pick randomly the colors of the planets and their size. Okay, so let's do that. Let's say that this code is now commented out. So this will not be needed anymore. And I'll just write a for loop that you saw before in one of the lectures where we talked about the loops. So let's do it again. Let's say that we want to iterate how many times? Let's first do like 20 times. And each time we iterate, we will create a planet. So let's make that like this. There's a new planet. And we want to provide the radius for that planet. That is random. But random function, if you know it, maybe you know, but it gives a number between 0 and 1. So if it gives like really a small number, you will not see the planet. If it gives larger number, it will be the maximum of 1. And let's thus make it a bit larger. Let's multiply it by 3, and that's gonna be a good radius. So each planet in the iteration will get a different kind of radius, but randomly. So you cannot really control it. You could remap those values. We will not do that now. We will just create random planets with random radius. Some of those will be really small, but that's not our main purpose here, to optimize these details. So another thing that we need is a center of our planet. And to create the center, I'll be doing some magic here, which will create the coordinates randomly within a certain range of a cube, and it will go from minus to plus x and y and z coordinates. So I'll just code it and you'll see how that works. So I will just first say that I want to have a sort of variable that is also random. So decision maker x is going to be math.random, and I want to create a param if decision maker x is higher than 0.5. So sometimes the param x will remain 1, and sometimes it will turn into -1. So sometimes the coordinate will be positive and sometimes negative for the x. The same we will do for y. So param y is like that, and param y is like that. Okay, so you see that I copied a lot of code, and actually, because we copied a lot of code, it's much better to say that we have a function here, right? We learned about functions. We'll define a function here. Give us, so get param for coordinate, and we'll just copy paste this code, and we don't actually need the x and x and x and x here, because it's a generic function, and we'll return the param as an output of this function. So this function will not take any inputs. It will just generate a random parameter like 1 or -1. And now what we can do, instead of typing all of that multiple times, as you see here, we will say param y is this get param for coordinate, and we'll say param x, and actually these can now be constants because they will not vary in time. So param y, and we can delete this code now. We don't need it anymore. And const param z is this dot get param for coordinate like that. This will just represent if the coordinate is negative or positive in the coordinate space, but the value itself will be represented also by a random number. So we'll say that coordinate x is math.random times 25, for example. We can also define this 25 as a certain space size constant. So let's say that this is space size, coordinate x is this coordinate y, and coordinate z. This can also go into a method, but it's so short that there's no real use for that. Okay, so now this constructor is still so first we need to provide the ring rotation speed, and that's just gonna be math.random divided by 40. So this is a small number always, and that's fine. The third parameter is the center of the planet. So this is where we will use those parameter x and coordinate x values. And param y times coordinate y, and param z times coordinate z. And another thing that we want is a planet color enum, and we want to also randomly generate the color for each planet, and this is what we'll do now. So we'll say again, it will be similar principle to this getting the coordinate. We can also just copy paste this code to get ourselves a random color. So basically, decision maker will be again random value, and default color will be planet color enum.blue. So this is something that will be default. If decision maker reaches, because we have three colors, right, in the enum, we will say that if decision maker is higher than 0.33 and decision maker is lower than 0.66, then our param will be planet color enum purple. And we can just rename this to color, because it's not actually the param anymore. We will decide on the color itself here. And else if decision, so another possibility is that if decision maker reaches a value that is higher than 0.66, then our color will be planet color enum white. Yeah, so this is not correct brackets. This is how we do it. So we didn't really yet talk about the logic or these if-else statements, but they are quite self-explanatory here. So I guess you understand how that works. If the decision maker value is higher or equal to 0.66, we assign the color to white. And if it's lower than 0.33, then nothing actually happens and it just remains blue. So this is how this works, and this is where we use variables quite nicely, right? Because we use this let operator and we define the color to be blue, and then we change it to purple or white depending on some conditions, and then we just return it. So let's say that our planet color is also a constant, and we can call our get random color method to give us a color. And now we can have this planet color here. Here I forgot to call the thing. And what's nice now is that we create this planet. We can await and call planet instantiate and draw. This was an incorrect way to do that. Okay, so now we really call the function that we defined here. We get the random color, and now let's see what this method does. So voila, we've created a space full of planets. Well, not full. Okay, we have how many planets? We have 20 planets here. And you see that the rings aren't rotating yet. because we still have some work to do. But in principle, this is working quite nicely. Okay, so the code has created 20 planets. It instantiated those planets and drew them. So we want to wait till all of those planets are drawn. And then we want to apply this rotation animation that we implemented before, that we saw before working. So what I'll do is I will create a constant called planet promises. And again, we didn't yet talk about the synchronous methods, but what we can do is we can, because this method returns a promise, we can just say that we push it to this array of all the promises. So we call it like that, and the result of it will be pushed to the planet promises array. And then in TypeScript and JavaScript, you can await on all of these promises by doing the await promise.all planet promises. So this computation takes a while to complete. This is instantiation and draw. This goes ahead into Open Cascade worker, does some work, creates the meshes, etc., draws them. And when this is all done for all the planets, then it's safe to say that we want to register the method which will rotate all of those planets. So another thing that we want is to collect all of those planets into array as well. So this iteration runs, and we want to say that planets will have each planet by using this push method. Okay, so now the planets are filled, and we can just say that this is a instance of a type will be an array of planets. And what we can do is we can go ahead, copy this method, uncomment it. We can also just delete that first part completely. That's not needed anymore. So now we don't really have planet 1 and planet 2, but we have planets, and we can iterate through them like that. So planet, we saw first that we can use for off loops. This is another way to iterate through the collection, and this time we will use it. It's for each loop, and in for each we will call rotate rings like that, and this will be called each rendering cycle. So rotate rings, that is a method defined here in the class. It just rotates the mesh around the vector in Babylon, and this is something that is safe to do. It's fast because it is a mesh. It's not an open cascade geometry or something like that, which will be much more expensive. And rotations are not asynchronous methods, so you can just do that here like that. Okay, so now let's hit run, and you'll see that each planet has a ring entity that rotates around different randomly generated vectors. So this looks fun, and we can navigate this surrounding. You see that planets were placed in random places. Some planets are really, really small, and might be that the rings look a bit strange on those, but yeah, I'm pretty happy with the result. Another thing that we can just maybe experiment with is, say we want, I don't know, 200 planets, right? So that's gonna be more, and voila, we are generating those now. You see that we've got a really crowded space here, and it still performs really well. It's fast, it's rendering really well. What you can do, of course, is, because it's so crowded now, you can increase the space size to something like 100. So it will span between -100 and 100 in all of the coordinates. And this will create a bigger cosmos. You see that now we have way more planets rotating around with the rings and floating. and some are colliding, collapsing, because that's the nature of randomly generated coordinates, right? So if you want to control those distances, you'll need to do something more interesting. But yeah, I think you get the point how you can use classes to create behaviors of objects. You can have fields that represent various kinds of attributes of those classes, and you can instantiate multiple instances of classes automatically in iteration loops. We also created few functions. That's nice to sort of repeat the concepts that we've learned in the previous lectures here. And if you scroll back to the planet class, you see that our sphere mesh is declared, but its value is never read. And that's fine. We can also just delete it here, and the code will function fine. It's not then needed, and the rings mesh will be used in the rotation method that we've implemented here. Okay guys, so I hope you have a feeling now of what the class is, how it can be used, how you define the class, how you instantiate the class. And yeah, I hope you guys enjoyed it. I hope you learned some things about the bit-by-bit, Babylon even, and TypeScript of course. Let's see each other in the next videos. Cheers guys.